Good evening friends. Today we are going to discuss basic Hadoop commands. So this is the continuation of previous class. In the previous class we saw how to install Ubuntu, how to install Java, how to install Apache Hadoop, right? Now if you have followed that step, now the next would be learning the basic Hadoop commands. So we have a system here, Ubuntu system. Now Hadoop we have installed in this location /user/local Hadoop, right? So inside that you have a folder called logs, where you'll get all the log related information related to name node, secondary name node, job tracker, task tracker, and etc. So when you are working with your program, okay, and if you get any issues related to name node, related to secondary name node, related to job tracker, task tracker, so the best place to look at is this one. Okay, now we are inside the logs. I'll say clear. Let's say ls. You see, this is data node log, this is job tracker log, this is a secondary name node log, this is task tracker log, this is name node log. So if you get any problem related to name node, sometime if you make mistake, you will get some sort of error while formatting your name node. If you get that error, you just go and look in this location. Okay, so any issue if you get related to these Hadoop daemons, you just check the log of this. Now what is the command to see the content of a file? Linux command. What is the command to see the content of a file? You can do cat, you can do more also. Okay, so I am pretty much comfortable with more. I generally use more. File name, okay, so you can use more command, you can even use vi to see that in the edit mode. You can use cat, everything is okay. Next, now let's try to see the basic Hadoop command. Now Hadoop we have already installed. Now the first thing what you need to do is you need to start the Hadoop. Okay, when you restart your virtual system, when you restart your Ubuntu machine, by default the Hadoop daemons will not be in the running mode. Alright, so just say start. First you do JPS. Okay, see, only JPS is running, other services are not running. That means Hadoop is not running now. So what the command to start that? Start -all.sh. Okay, so now your Hadoop processes are running. You say JPS. It's not it. Again, we have also seen that we can access the Hadoop file system using web interface. Do you remember the port number of that? Localhost :50070. Okay, this is the port. This is the port from where you can browse the HDFS file system. Okay, from where you can browse the HDFS file system. So I have just added few files here. By default you will not see this Hadoop. By default you will not see this word data. Let me clear everything. Okay, we'll clear it later. Now the first thing is, let's try to understand how to create a directory. What is the command to create directory in Linux? mkdir. So similarly, okay, when let me go to cd home ls. Okay, I'll say mkdir hello, or let's say data. Is there any folder called data? No, data. When I say mkdir data, where it will create the folder, in the local or in the HDFS? In the local. So when you say mkdir data, it will create a folder in the local file system, data. Is not it? Similarly, I want to create a folder in HDFS. So in order to create the folder in HDFS, you need to use this command Hadoop HDFS, then your command, sorry, um, Hadoop FS, then your command. Okay, HDFS related command FS, job related command jar, to execute the job jar. Okay, and all other file system related command Hadoop FS. Now let's try to create a folder. So what is the command to create a folder? Hadoop FS hyphen mkdir, your folder name. I'll copy this. Okay, so when you install your Hadoop cluster for the first time, okay, you'll only see these two folders, app folder and user folder, and inside this user you'll get your user folder, SD user. Okay, so in a cluster we have only one user, so we got only SD user. Inside this you will not see anything. Alright, now let's try to create a folder inside this SD user. Let's try to create a folder inside this SD user. I would like to create a folder called data. So okay, we'll create data one only. Copy this command and paste it on your terminal. Clear, paste Hadoop FS hyphen mkdir data one. That means create a folder called data one, where this data one will be created. This data one will be created inside your users folder. What is the username? What is my Hadoop username? HD user, right? My Hadoop username is SD user. So when you say mkdir of data one, it will create that inside your SD user only. Okay, so you just check it out. Go to user, go to SD user, we got a folder called data one. Now if I write /data1, what will happen? Let's see. This will create a folder here. This will create a folder in the root. Are you getting the difference? So please make sure whenever you perform any file related activity, this slash makes a lot of difference. Okay, you can also give a direct path like this. I want to create a folder called data2 now. Okay, or a test data /user /sd user /test data. You can create a folder in this way. Otherwise this entry is optional. Okay, we just directly write test data. It will automatically create in the current work. It will create on the default home directory of SD user. Okay, now in Linux, okay, let me just say present working directory is SD user. I want to create a folder like this, mkdir. I want to create a folder, let's say test1, which does not exist. Inside that I would like to create test2, which does not exist. Inside that I would like to create test3. Enter. So it is not allowing us. What is the command? How can we resolve this? Are you getting my point? It is not allowing us because there is no folder called first of all there is no folder called test1. Okay, and inside that test2 there is no folder called test2. But if you want to do this recursively, then you can use -p. The meaning of -p is first you create test1 if does not exist, then you create test2 inside that if it does not exist, then you create test3. Okay, this time it did not show any error and the folder got created, ls test1. Inside that you have test2, inside that you have test3. Okay, lsr test1, lsr is not supported here. Okay, ls test1 test2, ls test1 /test2 test3. Getting my point? Now, but in case of HDFS, it is not compulsory to have all the folders created. If it is not there, Hadoop will automatically take care of it. So the command is Hadoop FS mkdir create a folder called data2, where this folder will be created in the root or in the SD user. In the root or in the SD user, in SD user, right? Because we have not given slash. Enter. Done. Refresh this page. So we got data2. Inside that you will get data3. Inside that you will get data4. Okay. Similarly, let's say I want to create many folders at the same time. There is a location called data. There is a location called data. There I want to create many folders at the same time. So the command would be Hadoop FS -mkdir. Okay, data folder. Inside that I would like to create logs folder. Okay, in that I would like to create error folder. In that I would like to create properties folder or configuration folder. Okay, say enter. Done. Now these folders are created where? In the SD user or in the root? Again in the SD user only. Okay, just go to SD user and you will see data folder got created. Inside that you have conf folder, error folder, log folder. Otherwise you can you need to repeat this step again and again, right, as a separate command. Okay, now let's talk about ls command. Ls command is basically used to see the list of files and folders. Okay, so this is similar to your ls command. This is similar to your ls command in Linux. So I want to see what are the folders present inside the data. Okay, so how can we do that? Hadoop fs -ls. All right, now the folder name. What is the folder name? Data. The folder name is data. Say enter. Okay, you can check inside the data I have conf folder. Inside the data I have error folder. Inside the data I have logs folder. Alright, now if you want to see the files and folders present in the root of Hadoop cluster, so the command would be Hadoop fs -ls slash means root, is not it? You got 3 folders: app folder, data1 folder and user folder. Now suppose I want to see the files present inside the data, right? So we have already seen ls data, and you can also write Hadoop fs -ls fully qualified path /user /hd user /data /conf. Sorry, I was supposed to do till data, right? Same 3 files. Now what is the command to get inside a folder in Linux? I would like to go inside a folder. I would like to go inside a folder. cd, right? So we can let's say ls. I would like to go inside test1, so I will say test cd test1 ls. I would like to go inside test2, cd test2, right? So on. Let me come back. //pwd. Where am I? Okay, I am in the root. Now similarly, let's say I would like to go inside this SD user data folder. Okay, I would like to go inside SD user data folder. Now let's say /user Now Hadoop fs hyphen l hyphen cd, and folder name data, enter. Is not it? Because this data folder is present inside my SD user, so no need to give anything, directly data you can give, enter. Okay, what it is saying, it will complain you saying that cd command is not found. Okay, it will complain you saying that cd command is not found. The reason is there is no cd support in Hadoop. There is no cd support in Hadoop. Okay, so that means in Hadoop you cannot navigate through file system. Why? We will see later, we will discuss later, but for the timing just get convinced that there is no command called cd to navigate through files and folders in Hadoop. Okay, now I would like to view the files and folders recursively. For example, uh, if I say Hadoop fs hyphen ls, okay, slash user slash sd user slash uh, okay, if I say like this, what is the output I'll get? What output will I get? Okay, I'm just trying to find out how many files and folders are present inside user hd user. So I got data is a folder, data1 is a folder, data2 is a folder, test data is a folder. Okay, but I would like to go I would like to find out recursively inside each folder, how many subfolders are there and how many files are there. Again, inside those each subfolder, how many folders are, again subfolders are there, and how many files are there. Okay, so for that there is a command called lsr. Okay, lsr. So the command will remain same, only you just need to put r. R means recursive. Okay, now you check, there is a folder called data. Inside the data you will get a folder called conf. Okay, similarly there is a folder called data. Inside the data you have error. There is a folder called data, you have logs. Again you have a folder called data1, you have a folder called data2. Again you have a folder called data3 inside data2. Again you have a folder called data4 inside data2, data3, and finally you have test data. Clear on this? Okay, now let's try to understand how to copy a file from local system into HDFS. Okay, so what is HDFS? HDFS is basically Hadoop distributed file system. Okay, and we have a local file system, we have a distributed file system. Now I would like to copy something from local file system to distributed file system. So we'll do one thing. I'll say ls. Okay, let's create, I'll say remove okay, ls clear. Okay, so let's try to create a file very quickly. Let's try to create a file. What is the command to create a file? We can use vim or vi. Okay, I'll use vim word.txt. I'll press I, insert mode. I'll say word, right? So let's say apple ball, apple ball, apple cat, ball, apple. Let's say there is some words in this file. Press escape, press colon, W and Q. Now ls, okay, we created something called a word dot text. You can say cat to see the output. Okay, you can say more to see the output, right? So we have a file called word.txt. Now this file is present locally or this file is present in HDFS? This file is present locally or this file is present in HDFS? Yeah, it is present in local file system. Let's try to move this into our HDFS. Okay, so the command is Hadoop fs put. Do you remember I was talking about put in the initial days? Okay, Hadoop fs hyphen put local path and HDFS path. Local path and HDFS path. So let's do it like this. Hadoop fs hyphen put. Okay, local path is what.txt is present in my present working directory. Yes or no? This what.txt is present in my present working directory. So can I directly write what.txt? Okay, now I would like to copy that inside, let's say, SD user. I would like to copy that inside SD user. Okay, so let me just try with like this. I would like to copy it /user, yeah, /user /hd user. Okay, say enter. Done. Now you just refresh this user hd user. Okay, so our word.txt is copied here, is not it? Now you see, what is the replication factor? 1. What is the block size? 64 MB. Its actual size is 0.05, but the block size is 64 MB. Clear on this? Now similarly you can also do like this, /word2.txt, enter. F5. Okay, word2.txt. If you give a file name, then it will copy the data into this file. If you don't give the file name, then it will create a file on its own and it will start copying the data. Getting my point? Okay, next. Now let me do like this. I would say, can I write like this, ./word3.txt? Alright, now again let's go and refresh this. I'll go to SD user, I'll go to, okay, so you see we got word count.txt. Dot means the present working directory. The present working directory is nothing but /user /sd user, is not it? Similarly I'll do it like this. word4.txt. Will this work or not? I'm saying copy word.txt to word4.txt. Will this work or not? Done. Okay, let's see where it got copied. Say F5. word4.txt. So all these steps will copy to the present working directory. Now I'll do it like this. Will it give me error or not? Saying the file already exists. Will this give me error or not? please check the slash. Yes, so this will create in the root directory. Okay, it will not throw you any error. Word4.txt got created, but not here. You have to go to the root. Okay, now again let me try to execute the same command. Now what will happen? Will it overwrite or will it throw error? Let's check it out. Okay, it will always throw you an error. Reason is very simple. In Hadoop cluster, basically you will put all huge amount of data files, right? Let's say there is a file called log.txt. There is a file called log.txt which is of 4 GB, let's say, and it is stored in Hadoop cluster. Now you try to copy a log.txt from local disk to the Hadoop folders HDFS, but your log.txt is simple, simply a 1 KB file, and if it gets overread, then what will happen? All the 4 GB file will be lost, is not it? And it will again, the user will again have to reload the data. So that's the reason it will not allow you, to copy to overwrite. Okay, all right. Now next is, I want to copy multiple files into HDFS. I want to copy multiple file into HDFS. For that, let me create one more folder. I'll do like this. Hadoop fs -rmr. Let me delete all the files. Word.wordstar.txt. Okay, user SD user. It did not delete word2 and all. Let me check. Okay, now we'll go to local system. Okay, I have word.txt. Let me create one more file. What is the shortcut to quickly create a file without any content? What is the command to quickly create a file without any content? Empty file, touch. So I'll say touch word2.txt, word3.txt, word4.txt. Okay, so all these files are created here. Now I would like to copy this whole. Into my HDFS. Okay, so the command would be Hadoop fs -ls. Let me do it like this. Star dot, I'll say what star dot txt. Copy it to current working directory. Cannot access word2.txt. Cannot access this, no such file. Oh sorry, I was supposed to do put. Okay, enter. Okay, let's go to user, HD user. Word we got, word2, word3, word4. Okay, so we just copied the data from local to HDFS in a bulk. Okay, now what we will do is, let's do it like this. I'll say cd, I'll create a folder here, mkdir, mkdir data is my folder already exists. Okay, all right, I think it is an empty data, ls data. Okay, it does not have anything. Let me move this file into the data. Okay, so move star.txt to data folder, ls data. Okay, in the data folder I have moved all this data. Now let's do it like this. Let's copy this data folder. Okay, let's copy this data folder from local file system to HDFS, and this data itself contains multiple files. Are you getting my point? Let me remove fs Hadoop fs -rm data. rm are not empty maybe. Okay, so let's say f5 data got removed. Now I have a data folder here in the local ls. I have a data folder here in the local. It contains 3-4 text file. I would like to copy this into HDFS. So I'll say clear first ls. Now Hadoop fs -put. What to put? I would like to put this data inside where? In the local. Okay, sorry, in the HDFS present working directory. Enter. Okay, let's see what happened. User hd user. Okay, we got a folder called data and we got all the files here. Getting my point? Now similarly you have one more command called copy from local. Okay, which is similar to your put command. That means if you want to store the data, if you want to move the data, copy the data from local file system to HDFS, you can use put command, as well as there is a command called copy from local. Okay, that will also do the same trick. So I'll do like this. Let me delete the data folder from HDFS. Okay, this folder got deleted, this folder got deleted, data folder got deleted. Now again I will execute the same command, but I'll replace this put with copy from local. Copy from local means copy from local file system to HDFS. Enter. Done. You refresh this. Okay, you got a data folder here inside which you will get all the files. Okay, so this copy from local and put, they are very similar. There is a difference, I'll tell you, but they are very similar, and almost whatever you can do with put, you can also do the same thing with copy from local. Are you clear? Okay, in Hadoop, to copy the data from local file system to HDFS, we have two commands. One is put, another one is copy from local. Okay, both work similarly. The syntax and everything is same, but there is a very slight difference. We will see that later. Okay, now the usage of both the commands are same. Here instead of put, you just write copy from local. Okay, next. Next, now let's do it like this. Let me create a folder here in the desktop. Okay, this is a desktop. I'll create a folder. data. Okay, here let me create a file, new document. I'll say fruits.txt, or let me say log.txt. Okay, and here let me enter some sort of log. I'll do like this. I'll add anything. Okay, so let's say this is a log file produced manually. We are going to store this in HDFS save. Alright, what we did in the desktop, we created a folder called data. Inside that we created a file called log.txt. Now I will zip this, compress, create. Okay, so in the desktop you got a folder called data.tar.gz. It is a compressed file. It is a compressed file which contains a file called log.txt. Is not it? Now ideally if you want to get the data, okay, no problem, okay, no problem, Ratna. So if you want to get this file, okay, loaded into your HDFS, what you need to do, you just need to unzip it. You unzip it into a folder, and after that go inside the folder and issue the command. Is not it? So let's assume I don't have this file, I just have a zip file. So ideally you extract it, you extract this, extracted. Now you go to your desktop, right? You go to your desktop and then you just issue Hadoop fs -put or copy from local. Okay, and the file name, what is the file name? In the desktop I have a data, inside the data I have log.txt. okay, I would like to put it in present working directory. Enter. F5. log.txt. We got a log.txt here. Is not it? But I just don't, I am not interested to unzip this file. Let's say the file size is around 1 GB. So if I extract it, it will take a lot of time. Is not it? So let's say we will not extract it. Okay, without extracting I would like to do that. That is also possible. So for that, this is the syntax. Copy this, okay, and paste it. Now let's check the syntax. tar zxvf data.tar.gz. that means unzip this file, get the data fruit.txt. okay, get the data, sorry, not fruit this time, this is log.txt. log.txt, send the output of this to Hadoop fs -put, where inside this folder my data fruit.txt. I'll just say I'll delete this and let's say log1.txt. Enter. Okay, so in the present working directory you go log1.txt. so what happened, we did not compress any, we did not unzip anything manually, right? But through our command it got unzipped. Okay, we just got one file from it, and we wrote that file into our HDFS. Clear on this? Okay, so if you want to see the content, you can see the content here, log.txt. This is a log file produced manually. We are going to store it in HDFS. Now, if the file size, what is the size of this file? Hardly 1 KB, right? If the size of this file is more than 64 MB, it will be divided into 2 blocks. Agreed? So at that time, you'll also get a pointer here. Next block, previous block. You click on next and previous to navigate to the next block. Okay, because let's assume I have a cluster of 4 nodes. Okay, I have a cluster of 4 nodes and I have a file of 100 MB. So this file will be divided into 2 blocks. One block will be stored in node 1, another block will be stored in some other node, let's say node 2. Is not it? Now, how are you going to navigate? So here in this web interface, it will also provide you next and previous. When you click on next, when you click on previous, it will automatically take you to the next block. Okay, and that block might be stored in some different location. Am I clear? All right, let's move to the next. Now I would like to write some file. I would like to write some file in the Hadoop directly in the HDFS. Okay, so what is the command to write the file in Linux? Vi. Is not it? Similarly, let's try to do that. Vi Hadoop fs hyphen vi data1.txt. Okay, vi is not supported. Getting my point? Vi is not supported because HDFS and your Hadoop is basically for what? Write once and read multiple times. Okay, now assume that you have a file of 10 GB, a text file of 10 GB, and if you would like to write something in that, it does not make any sense. Is not it? Because usually in Hadoop we will give a huge file for processing, and definitely huge file means these are generated automatically by your softwares. These are generally created and generated by your sensors, right? No one is going to write a text file of 10 GB. So that's the reason VI is not supported. What is supported? You can only upload the file. You can only upload the file and do some processing in that. Now let's assume that you have a file called abc.txt, or let's say data.txt file, okay, which contains employee records. You have written that file into HDFS. Now in HDFS, after writing that file into HDFS, you found that there is some error in the file, okay, and you would like to remove that error. What you need to do? You need to again get back that file from HDFS to local. Bring that file from HDFS to local, okay, open that file and do the modification. Once modified, again write the changes back to your HDFS. Okay, so you will not have direct access to edit the file on the fly from HDFS. Clear on this? Alright, now I would like to create a file in HDFS, but input source will be my keyboard. Okay, input source will be my keyboard. So how to do that? Hadoop fs hyphen put. Okay, Hadoop fs hyphen put, then your input file, right? So you just write minus input file, okay, hyphen, and what would be the destination file? Let's say myfile.txt. Enter. Now when you do this, it will allow you to enter the data. Let's say my name is Suraj. I want to write this content in myfile.txt that is present in HDFS. Okay, after this you press Ctrl C, enter. Okay, you press Ctrl C. Now you go and check your SD user. Myfile.txt you got. Click on this. Come on, it is supposed to save the data. SD user myfile.txt, it did not save any data. Myfile.txt, now I cannot do that because it already exists. Let's say myfile1.txt. okay, hello world, enter, Control C. Okay, now let me check F5. Alright, so you need to press an enter. Okay, I did not press an enter, that is the reason it did not save it. So when you say 2.txt and then you start writing your lines, finally you press enter. After that only you say Control C. Clear on this? So if you use this concept, then you can write the data into myfile2.txt from your keyboard. Control C to exit. See, now I got access to my terminal. I am writing something. Hello, how are you? I am fine. Now I need to quit, right? Okay, so you say Control C. So Control C will quit, and whatever you have written here, that will be stored on your myfile2.txt. Okay, now this is what we discussed, how to write the data from local file system to HDFS. Let's do the reverse. Now I have a file in HDFS. Let's say it like this. I have a log file in my local file system. I uploaded that into HDFS, and then I executed my MapReduce program. My MapReduce program started working on that, and finally it gave me some output in one file in HDFS. Now the output of my process, the output of my program is stored in HDFS. I would like to get that data from Hadoop to local file system. Getting my point? We uploaded a file for processing. Processing is done. The output is written back into another file. I would like to retrieve that file into my local file system so that I can see what is the output and I can do some program on top of it. Okay, so for that you have a command called get. Okay, get. In this get you need to write source and destination. Yes, file type can be anything. It can be text file, it can be mp3, it can be any other files. Okay, so Hadoop file system -get source. Now here source will be HDFS source or local source. Get. forget what will be the source, what should be the source, local source or HDFS source. I want to get the file, right? So get the file from where? HDFS. So in HDFS, I have a file called log1.txt. So it is present in the same working directory. I can directly say log1.txt. I would like to copy this file. Into my uh, desktop. Okay. So let's say log33.txt. This is my destination. This is my source. This is my destination. Enter. In the desktop, you see there is a file got created log33 with the same content. Clear? Similarly, I want to see this file. File content as an output. I want to see the output of this file on the monitor, on the console only. So what you do, instead of this destination, you just say hyphen, enter. Getting my point? Now similarly, you have one more alternate command to it. The alternate command is copy to local or from local. Copy to local. Okay, copy to local. Copy from local means from SDFS, sorry, from local to SDFS. Copy to local means from SDFS to local. Let me say log33 txt 333.txt. Done. Okay, now let me tell you what is the difference between these two commands. Okay, copy from local and get, put versus copy from local, and get versus copy to local. Okay, ideally if you look into the code and all, there is there is no difference at all. Instead, there is a class called copy from local, there is a class called put. Okay, and your copy from local actually is extending put. Okay, but generally when we say put and copy from local or to local, okay, to local always means I want to do some activity with local file system. Okay, and put means I would like to I would like to do some operations not with the local file system but with any other file systems also. Okay, for example, there may be a situation where you would like to copy the content from one SDFS location to another SDFS location, and both are present in two different clusters. Let's say I have a cluster 1, I have a cluster 10. In the cluster 10 there is a file. In a cluster 10 you want to write the data from cluster 1. That means I would like to write some data from cluster 1 to cluster 10. Okay, so in those place your put will be effective, but copy from local means always the local file system. Getting my point? Okay, now which one to use, copy from local or put? Which one to use, copy from local to put? You can use copy from local also, but I will recommend you to use put, because as I said, there is no actual difference, and put is very short command, right? Instead of copy from local or copy to local, put and get is a very short commands. So you try to use put. Okay, always try to use put and get. Okay, now in the HDFS, once you write the data, okay, you can set the replication factor. What is the replication factor here in our Ubuntu? 1, right? And if you have done this installation properly, then you might have found that in one area we have also set the replication factor, right? So that's the reason it is giving you 1. Otherwise the default, if you don't configure that, then default will be 3. Okay, so I would like to change the replication factor of a file. Okay, so let me go to SD user. Here I have log.txt. I would like to change the replication factor. Hadoop fs hyphen setrep. Okay, I'll write it. Hyphen setrep. Setrep, let's say replication factor 23. Okay, which file? Log1.txt. Enter. Replication 3 set. Okay, say F5. Now the replication is set to 3. Okay, similarly you can change the replication factor of various files. Alright, so even if your cluster size is even if the cluster default replication factor is 3, but still you can customize that manually. Okay, so let's assume that in your Hadoop you have only 4 terabyte of hard disk space, or let's say only 300 GB is available. Only 300 GB is available. Now you have a file of 1 GB. Okay, and you have a big file of 100 GB. So if you set the replication factor of 100 GB to 3, what will happen? Everything will be occupied, right? So what I will do is I will set the replication factor of this 100 GB to 2. Okay, so that 200 GBs will be occupied, and still I'll have 100 GB available. Getting my point? Similarly, let's assume that you have a cluster. Okay, you have a cluster, and in that cluster the available space right now is 1 terabyte, and let's say you are almost your hard disk of the clusters are getting filled. Now you have only two options. You add one more node, is not it, so that you can get extra spaces. Otherwise you decrease the replication factor of those files which are consuming heavy memory. Getting my point? Okay, now when you say mkdir, when you say mkdir, so it will interact with which daemon? When you say mkdir, it will interact with which daemon in Hadoop? Task tracker will come into picture only when you are doing some processing. Job tracker will come into picture only when you do some processing. We are not doing any processing. we are doing SDFS label activity. Okay, see mkdir, ls, these are not actually your job processing. It is simply your performing one or other IO operations with SDFS. So name node will take care of it. Okay, so whenever you say Hadoop fs hyphen mkdir of data1, okay, where do you execute this command? In the terminal, is not it? We execute this command in the terminal. We open terminal and we execute this command. So this terminal is now client to our SDFS. Okay, this terminal is our client to our SDFS. Sorry, to our SDFS, and name node will take the request. So when you say Hadoop fs hyphen mkdir of data1, name node will take this request and it will say, okay, you are asking me to create a folder. It will create the folder. Okay, similarly, when I say Hadoop fs hyphen ls, I would like to get the data of a particular folder. When I execute this command, name node will take the query and it will check whether it will check what are the contents available for this file. Just go down, see this command Hadoop fs hyphen ls data2 slash data3. So when you execute this query, this command will go to your name node and name node will try to see what are the content available in this data3. How does it know? Through the metadata. Do you remember I told that name node maintains a diary? Okay, so the name node will check that diary to find out what are the components available inside this folder. Okay, similarly, when you say put, then the name node will take the request. Okay, it will see that okay, he is trying to copy word1.txt into this location. Right, so first what it will check whether do we have sufficient space or not. If no, throw error. If sufficient space is there, then only allow this and copy it to the if space is there, then it will check what are the nodes available and it will give that data node data to your client, and then the client starts processing. We have already discussed this, is not it? So whenever any request will come to write the data, first the name node will see whether we have sufficient space or not. Yes, then the name node will check what are the available nodes, the slaves. Okay, so it will give this slave detail to our command line, okay, to our put. So the put will understand, okay, in this cluster I have name node 1, I have data node slave 1, I have slave 2, I have slave 3, and I can write data in this slave 1, slave 2 and slave 3. Then this put will actually transfer the data. Okay.